Hey everyone, and welcome to the AWS Nordics Office Hours. My name is Gunnar Grosch, and I am a developer advocate here at AWS. I'll be your host, your MC, your moderator for this hour, where we, as usual, talk about one specific topic with AWS experts, but we also try to answer any questions you might have, be it on the topic, any other AWS-related questions about tech questions about how it is working at AWS, perhaps. And today, I'm very happy to be joined by Sini Tinfors to talk about streaming and real-time analytics with serverless. So thank you very much for joining us today, Sini.
Yeah, hey, thanks so much for letting me join.
So you are a startup solutions architect here at AWS. So what does that role mean?
Solutions architects typically would help customers to figure out, as you know, the portfolio is quite broad by now. And for many who it can be quite overwhelming to know which services to choose when, like, which building blocks to put together and how to put them together. And that's typically something that I, as a solutions architect, help our customers with. And I just also happen to be privileged to work with startup customers. So that's what the startup part means. So typically I work with startup customers in the Nordics to figure out how to build with AWS.
And the startup scene, for anyone who doesn't know that in the Nordics, it is really strong. There are a lot of startups in the Nordics. So I'm guessing it's quite thrilling to work with that scene as well.
Yeah, absolutely. And before joining AWS, I knew I was, before joining, I was already a huge AWS fan, and so I figured I would love that, and I do. But what I actually like even more is to meeting with startups and getting to be just to take part of their story and the journey that are startup. And yeah, so that's more than I ever would have thought or expected when joining.
How long have you been with AWS now?
So it will soon. Let's see. It's February now, March, April. So in 3 months, I actually have my 2-year anniversary.
Okay, cool. So all of my guests, more or less, have been here longer than I have, but I guess that's good. So you can be called AWS experts compared to me, all of you. All right, so we're going to get back to Sini really soon. First, I want to show you the schedule of our upcoming sessions. As you know, we have these every Monday, 1 p.m. CET, where we have AWS experts on to talk about the specific topic. And the upcoming ones, well, next week, we're going to talk about serverless ops, operations for serverless with Nicholas Muchen. He's one of the serverless specialist solution architects based in the Nordics. Week after that, we have containers, then we have AI ML, we have machine learning sessions, we have a secret episode. Let's see what that is when we get there. And then one on databases. And also, I want to remind you that we have this opportunity to schedule one-on-one meetings with AWS experts. So not only are you able to watch us live on Twitch and ask questions here, you're also able to schedule meetings with AWS experts. And to do that, you just go to our webpage for this office hours. I'll post a link in the chat as well. And then you're able to click the orange button and schedule a meeting. So take advantage of that opportunity. If you have anything in particular you want to talk about, special type of technical solutions, ask questions about how to build on AWS. All right. So with that, back to the topic of today, streaming and real-time analytics with serverless, Sini. I think we need to break that down a bit to know how to approach it. So should we start with the streaming part, streaming data, I suppose it is. So what does streaming data mean?
Absolutely. Yes. So so streaming and data, typically what we mean by that is something that is continuous, meaning there's no fixed start and no fixed end to that, but rather we have data coming in continuously, and also what we mean by that is like it's typically a high volume of continuous data. So that's typically what I mean when I say streaming data.
What can be a typical source of this streaming data then?
So really, it's pretty much any workload you can think of. So it could be, for example, I would actually say like any web page that you're browsing, or any system you're using. It can also both be related to like how a system is doing, or a clickstream coming from a web page, or it could be devices that are producing data. Like any, really, it's quite broad. So it can really be nearly anything that produces data.
And looking at the type of systems, the applications we build today, they all create massive amounts of data, and streaming that data is well, that brings us to the next part then, real-time analytics. How we want to use that data in a way for it to make sense. So we not only just creating data and storing that, we want to use that data in some way. Mm-hmm. And tell us about the analytics part.
Yeah, absolutely. So typically data, I think it's such a good example. I don't know, Gunnar, how long you've actually, when you started work, how long you've been working, but I've worked for quite a number of years now, and I just like I love seeing the change over time. So like when I started out, we had this like thinking now about my employer at that time, we had this yearly employee satisfaction survey. It was like a yearly thing. It was like page after page after page, and then it's dreadful to respond to it. And then 3 months later, we get the response, and typically that wasn't even relevant anymore. And versus now, we have this even. In the past couple of employers actually had like daily questions that we answer, of course. And I think this is so good because this data is really mostly valuable now. I mean, what we answered in that survey 9 months ago is not even true anymore. So I think it's kind of true that the value of data is highest with the more current it is. So like older data isn't as valuable, meaning that if we can actually gain insights from this data, from what happened just now, we can produce a lot more higher value services. For example, on a web page, imagine you could, before get a report at the end of the day, versus now when we're actually browsing the web page, depending on, instead of if a user doesn't find what they're looking for, we can imagine if we actually use that data and like recommend items that would be interesting for them. I think that's a good example of how the value or the data is more valuable if we can actually analyze it of like what is actually happening in real time or near real time.
Yeah. So then we've talked about streaming data. We talked about real-time analytics of the data to use that data in a meaningful way as it is created, more or less, as soon as we can use that data. So let's talk about some of the use cases we have there then. You mentioned devices before as well. So I suppose IoT is a big use case for this, both streaming data and then real-time analytics of that data, because we have perhaps a fleet of many IoT devices out there, and all of them are creating data all the time. It might be temperature data, it might be any type of environmental data that is created and then streamed into AWS Cloud to then be used for analysis of that data. I think that's a great use case for this type of solution. So any other, or should we ask perhaps, what is the kind of problem we want to solve them by building these types of solutions? Because I'm guessing that it isn't that easy to have these massive amounts of data and to then analyze them efficiently as soon as they are created.
So I think you're right in the sense that in the past, it has not been so easy. and it is just like with many other AWS services, AWS is really making this a lot easier for users. So therefore, we're also seeing, so like going back to those customer meetings, then I have so many customers are asking about this topic. And I know, Gunnar, you're kind of a big serverless fan, and as am I. And to the point where I'm actually considering to refocus my specialty to analytics, because that's so many customers asking about it. And I think they are asking about it because it isn't as hard anymore as it used to be, and largely thanks to these managed services that AWS provides. But before we I wanted to just bring up one more use case that I think is really great, which I met a while ago with a customer who had a need to. They were working with risk, so they, depending on the user behavior in their system, they wanted to in real time analyze different transactions and be able to act on that. I think that's also another use case that in the past has been difficult, and to their business, it's really so useful to be able to get these real-time insights, which is both like reduces the risk for them, and also gives like much better customer experience for their users, because they can it like enables them to build new types of use cases and minimizing the risk. So acting on this, like not just analyze it, but then also take action. It's like the
yeah, I think, and that's a really great point about this as well. We have all this data, we're able to stream it into our system for analysis, and then to be able to use that for decision making, so that we're able to act on whatever happens within, be it with our IoT fleet devices or with any type of smart watches, wearable devices, or if it's a web application or whatever, but to use that data to make these decisions.
Yeah, and hey Gunnar, I don't know if you knew, I mean, I'm based in Stockholm in Sweden, and just like yesterday or last week in Dagens Nyheter, I read the story on how there was a grocery store now, and they had all installed these price tags in the food store, with just to be able to act like closer to the edge on things that are happening. For example, like they took the use case of bananas. Like they had for some reason a huge batch of bananas coming in, and they were risking going bad. Then they wanted to use these price tags to like lower the costs, or lower the price for consumers, just to make sure that food isn't wasted. And I thought that was so cool, just like that, seeing those, seeing where we're heading.
Yeah, and I didn't read that exact article, but I have definitely noticed in stores today that we have these electronic price tags, so they are able to update prices much easier and quicker. So they can use this type of data, the behavior of people shopping, and then make quicker decisions. With pricing, for instance, in grocery stores today. And I think that's a great use case for analytics of this real-time data. All right, so we talked then about the problems that we want to solve with this. And I suppose that is a great thing, a problem to solve, to be how to make these decisions quicker. Yeah. So how do we do this then? Why now? Why are we seeing this now? Because as you say, there is a big demand for making quicker decisions, for analyzing data. Why are we seeing this trend right now, you think?
So I think it's really the matter of what is now possible. So and I think we have to kind of like before the managed services weren't there, it was like hard and was cumbersome. You would typically operate with batch data. So like that kind of like opposite to streaming data would be batch data, where you process data in batches, and perhaps or at the end of the day, you could query this. Typically, quite complex system and complex queries. And again, data was like a bit outdated. But now, with just like I have to bring up the AWS portfolio of services which making this possible. And of course, I think many of you have heard of the Kinesis family. And the Kinesis family actually has 4 different services. And I think 3 of them are most relevant, and that's Kinesis data streams, which enables ingestion of massive amounts of data. Kinesis data analytics, you can hook that into a Kinesis data stream to do analysis on streaming data, and then Kinesis data firehose, which makes it super easy to ingest data and then to store that data into S3 or your data lake. There's also Kinesis also has a video streaming service, and so just letting you know that those are the 4 Kinesis services. So I think using these services has become it's very easy, and also there's also more flexibility in how to. So there are actually several ways to do analytics on this Kinesis data streams.
Yeah, so that the services are there to allow us to actually do this now in a much easier way, going from doing it batch-wise, as you said before, to now being able to do it in more real time as data is created and ingested into the system. I think that's a great explanation for why this happens now. But what is still difficult then about streaming data? We have these services that are able to do it, but what is still difficult about it?
Of course, I would say some things that are still isn't entirely taken care of by managed services. Of course, the complete checkpointing. Customer will still need to have some custom logic in their application to make sure that messages aren't processed twice, for example. So that's something that's still hard. But I think overall, I'm guessing that I think the kind of like the lack of experience. So I think a lot can be overcome by just actually getting started and trying it out and getting more familiar with it. Because the great thing about, for example, what we'll be showing in the moment from now is actually Lambda consuming events from a stream and doing simple analytics there. Like you can, even if what the analytics, it's like, for example, we'll look at aggregations. Even if that's not complex or hard, just like getting started and getting familiar and getting your hands on with it, it's kind of like takes most over that hurdle of not even knowing how to start.
And you touched on Lambda there, because at the end of today's topic, streaming and real-time analytics with serverless, we have that word, serverless. Yeah. So building these types of solutions using serverless services, what are the benefits with that then compared to non-serverless? I guess that's back to the serverless value proposition.
Yeah,
what is the serverless value
Absolutely.
proposition?
Oh, great, serverless. Love talking about serverless. So the main benefits about serverless is, of course, that you don't have any servers that you need to manage on your own. And it's really easy to get started, but the main benefit is that you're only paying for what you consume. So if you don't have any messages in your stream and no Lambda's consuming them, you're not paying anything, which it's very cost efficient.
Yeah, and looking at the type of data that you perhaps would ingest into your system, well, it isn't always a constant stream of data. It would, looking at a grocery store, for instance, I'm guessing that they have more data being created and being ingested into the system while the store is open, perhaps. And the same with IoT devices, with wearable devices, with cars, whatever type of data you're having. It is data that sometimes is a very large amount of data, and sometimes it's a lower amount of data, which means that serverless is a great fit, because you only pay for the usage you have. You pay for what you're using. Exactly. So cool. Exactly. All right. So is it time perhaps to move into showing an example of this?
Yeah, I think so.
Yeah. So
let's do that.
If you've just joined us, this is the AWS Nordics Office Hours. Ask me anything, as always. Today, we're talking about streaming and real-time analytics with serverless. And I am joined here today by Sini Tinfors. She's a startup solutions architect for AWS in the Nordics. So, Sini, please share your screen, and I'll put that up. So we can see an example of how to do this using AWS services. All right, there we go.
Cool, this is work. And hey, Gunnar, I know you're a developer advocate, and I'm sure you do demos a lot. Did you become a fan of Cloud9 yet yourself?
I like Cloud9. No, I like Cloud9 because I actually used it way back when it was very young service, and I like it because you're able to especially in these types of situations, you're able to demo using a solution that is browser based, and you have the same look and feel for everything you're doing. You're not tied into a specific ID. So I like it, definitely. And also, you have access to all the different tools in the CLI and so on that you need straight away.
Mm-hmm. Yeah, no, same here. I love China. I was using it. So before joining AWS, I actually worked in a company that did streaming data, and we were using Kinesis, and we were picking up. It was an IT use case, so we were picking up data that was like each of these devices were consuming, and doing all sorts of analytics with this. And we used Cloud9. It was so great. Especially how you can just like create new workspaces for, like you said, for demos, because I love doing it. I think these two use cases, these are both new from reInvent. And I think to fully grasp like how it works and why it's good to actually try it out yourself. So the demo. So the let's see. These are I know that. All right, let's discuss what we're gonna demo a bit before. So I know that in the past we've always said that all lambdas are stateless. You can't have, it's an anti-pattern to sort of have or you're not really allowed, or you're not. It wasn't possible to even like pass state from one Lambda function to another. And with this year's reInvent, a new feature was launched, and I think it's called it's called Tumbling Windows, and it's for a long time Lambda fan like myself, it's a bit mind-blowing that now you actually can pass state between Lambda functions. So what it does is that it allows you to define a window of let's say 1 minute or 30 seconds, and then for consuming a stream. So for example, either a DynamoDB stream or a Kinesis data stream. And for each invocation, within that window, it allows the Lambda to add for example, the sum, and then at the outside of that window, you can store that data somewhere. So in this demo, we're going to look at sales figures, and within each 30-second window, we'll add those and we'll send those to a DynamoDB table.
Perfect. And I am very impressed. So if I look not impressed, no, that's just the way I look. Sorry about that.
All right. And hey, Gunnar, I have a great idea on what we can do with this functionality in the future for your viewers as well. So I'll share that in a moment.
Yeah, please do.
So here I have my SEM template. and it is a serverless application model. It makes handling CloudFormation templates easier when you're using serverless functions. So I have a Lambda function that is invoked by a Kinesis stream, and the Kinesis stream right here. And I have the Tumbling Windows functionality enabled. So my tumbling window here in this case is 30 seconds. And at the end of each 30-second interval, actually will, as I mentioned, I will store this in a DynamoDB table. So that is what I have deployed in my AWS account. And then I also have a data generator that I don't have any actual web shop, unfortunately. So I have to generate some dummy data. It just takes the timestamp and the sales. And then it will, I'm just using one partition here.
So this is just to simulate some type of data that is being ingested into the system.
Exactly. So, so I have, this is just my data. So now I'm actually generating data, sending that to my Kinesis stream. And then let's have a look at the Lambda function. Let's see, I think, there we go. I have a lot of Lambda functions. So let's have a look at the Tumbling Window Lambda. And I'll have a look at the monitoring here. And we're going to actually have a see if I think easiest way is to understand this actually to look at these, look at what happens in CloudWatch. So while this is loading, I think, wouldn't it be great if we could actually have get real-time feedback from viewers? So how about we make a simple app with all those like different emojis, and then whenever we're not being funny or interesting enough, or when we are really funny and we provide lots of insights, then there's our viewers could actually give us feedback real time, and then we could learn from that.
Yeah, it would be good, but it would put a lot of pressure on us as well to have that in real time. So you would see basically instantly if you were funny or not. So yeah, let's build that.
Yeah, I think it could be. All right, so let's see. Here we have the latest log stream.
So this is the log stream from the Lambda function.
Exactly. So it will. So let's see if we can find a good. So here we have a start. So let's see. We get the invocation, and so Lambda will actually get another. It both has the state, which has been passed from the and letting Lambda know whether it's the final invocation for this window. Because if it would have been the final invocation, then we're gonna set the state to 0, and we're gonna write that to our DynamoDB table. So this is maybe a little chatty, but we have the existing sales, and then here we see. I'm sorry, I've left some funny debug printouts, but we see that it is indeed adding it's the sales figure to the state, which is then passed on to the next invocation. And I can just show you what it looks like in DynamoDB. So here we have the Tumbling Windows aggregation. If I can maybe do this. I don't know if you can see this. Happy to try to make it bigger if it works. Not sure if that works. But what we can see is we have the window start.
Yep.
And 30 seconds later, we have the end of the window, and then the total sales figures.
Right.
So maybe we could make the time window for the viewer feedback like 5 minutes or maybe 2 minutes, and then just, although I guess we would then also need to keep track of what we were saying in those minutes of the video stream.
Yeah, and we got instant feedback on that as well. So people will not spam it. So that's good to know.
That's good. That's perfect.
Yeah.
Perfect.
All right.
Yep. So that is the tumbling window.
And as you mentioned, this functionality was launched during reInvent as a new service feature. And how would you have gone about building this before you had this feature?
Yeah. So before this could actually be done. Oh yeah, we never really went into that. But there, as I briefly mentioned before, we also have a service called Cloudkinesis Data Analytics, which also reads which also can read from a Kinesis data stream, and that actually allows you to also do similar things. Either you can query Tumbling Window with SQL or with an Apache Flink application. And just actually in preparing for this a bit, I was actually chatting to one of my colleagues who focuses on Kinesis, and we got into an interesting debate whether what was easier. So my colleague's opinion was that the Kinesis data application, Kinesis data analytics, that would be easier, and the Lambda, this Lambda version that I showed you today, that is rather, if you then also need to, for example, connect with other AWS services, then Lambda is like a great option for doing that. So it's a bit on what you prefer. If you're perhaps a data scientist, you're familiar with Apache Flink, then maybe you want to go ahead and have that option. And but rather, if this type of analytics is part of like another workflow, then using Lambda might be your best choice.
Right. And as with many service features or announcements that we see, it often means that things that you previously had to build yourself, you had to write the code to handle certain use cases or functionality. Now you can leave that up to the service instead. So it means that it's less code for you to write, manage, and make sure that you own it, so you have to maintain it, make sure that it keeps on working. Now, Tumbling Windows is a built-in functionality instead that you can make use of. All right, that's cool. So thinking about use cases for this then, I suppose it goes back to pretty much everything we've talked about before. This is something that you can start using more or less straight away if you have those existing use cases. If you're already working with this is something that you can enable as well. Of course, some changes needed, but you can enable this and start making use of this feature. Cool. So next then, you mentioned that you have another demo for us.
Yep, absolutely. Have another demo as well. We can have a look at that one too. So this functionality that was also came at this year's reInvent, which, by the way, it starts to feel like quite some time ago now. The most recent reInvent. I don't know about you, but
2 months ago. But yeah, it feels like a lot more than that, for sure.
Yeah. So this one is it is a new functionality of stream processing, which allows you as a consumer to have greater control over what to do when a message fails to process by a Lambda function, for example. So it's called report batch item failure. You didn't have the as a function response type. So again, I'm using Cloud9, and this is my SAM template. And we're looking at the Lambda function definition here. So yep.
When would a message fail to process? What would be a reason for a message failure?
So perhaps it's I don't know, it could have gotten corrupted, or it doesn't contain all the data that was expected. Oh, Gunnar, help me out here. It seems like such an easy question, but when would a message fail to process?
No, but I think those are valid examples, but it might be, as you say, corrupted data. It might be incorrect data that is sent. It might be, depending on what the source is, a device, for instance, sending data. It might be issues with the device. So I suppose there are many use cases or many examples of when data would fail to process, for sure.
Exactly. And sometimes these messages that aren't processable, they were sometimes called, I think, poison messages or poison pills, because they could trigger, depending on how you had your setup configured, they could trigger retry storms, and so messages would just like be retried. And now, what if you have report batch item failures instead? When your Lambda function triggers with batch of events, it wouldn't actually try to reprocess it, or before the whole batch would stop processing, and then that whole batch would be retried again. But with this feature, processing would stop at the item that failed, and that will be reported back, and then only from the retries wouldn't retry the entire batch, meaning the successfully, also including the successfully processed events, but only from the point of failure and onwards. If that made sense.
Yeah, that makes sense. And I suppose it also makes a very big difference in how you yourself have to handle these failures. So tying back to the feature we talked about before with tumbling windows, this is once again a feature that makes the service more in charge of what happens with the failure. So you don't have to create, you don't have to write the code or handle the failure in the same way. You leave more up to AWS once again.
Exactly. And so in this, and I think it's going to be quite a lot easier to understand when I actually show you. So just moving on the SAM template here. This Lambda function actually gets triggered by a DynamoDB stream, and it's going to get batches of 10. And let's have a look at what happens, because here I will also generate some data. Let's see, so it's just a batch of 10, and let's have a look at what happens in our Lambda function. Let's see.
So the Lambda function we're looking at now, it is the one that is processing the stream.
Yes, exactly. And I should say, maybe I should show you too, because it's actually just, and the way to simulate an error here is actually that this Lambda function, you can see the function code here. It is going to have each fourth message is actually going to fail in this Lambda function.
Kaboom.
So kaboom. Let's see, where do we have the, let's look at what happens in CloudWatch logs for the batch that we invoke this function with.
While Sini is looking for that, if you just joined us, this is the AWS Nordics Office Hours with me, Gunnar Grosch. I'm joined by Sini Tinfors. We're talking about streaming and real-time analytics with serverless, and talking about some of the new features or announcements we saw out of reInvent in that regard. So right now, Sini is about to show us failures in batch of data.
Yep. All right. So then let's see if we can read this here. We let's see if we can resume. Can we get more messages? Maybe let's see if we can look at one of my previous invocations instead.
Okay.
Okay, here we go. This is a better one. All right. So we see we got a batch of 10 records. And 1, 2, and 3 were successfully processed, and then we got to the fourth one, which failure. And there it ends. And then we immediately see the next invocation. Here we have 7 records. So it's the same batch is retried except for the ones that were successful. And again, the coming 3 were successful. Again, the 4th one failed. And then it continues, of course, with the next batch that is 4. The last one would fail. And then on the next page here, you're going to have to trust me that in the next batch, all of them were successful. And then, of course, you can control this behavior additionally with the number of retries. So again, this allows us as when stream consumers to kind of control retry behavior when batches of messages are processed.
Right, and then the failed messages, what are you able to do with them later on then?
So the failed messages, either you would be able to, you can either send them to you can set the destination of where to send them to. So either SQS or SNS, and to sort of separately, after a number of retries, you can decide how you want to treat those messages.
All right, cool. So you can inspect the messages or then manually retry them, perhaps.
Mm-hmm.
Cool. So can we switch back to Cloud9 and just have a look
absolutely
what was needed to be able to enable this, I suppose, in your SAM template then.
Exactly. So all that was needed, it's on, and maybe we can actually also look at this in the Lambda console, but so before Rement, we did not have the option to have report batch item failures, and that's the function response type that you set.
And that's it.
That's it. So no more than that, actually.
That's fairly easy then to be able to do that. Cool. So I think that's a great example of a feature that is announced, a feature for service that then makes it easier to build these types of solutions, to be able to handle failures, because failures will happen even in these types of solutions, because the data that you are streaming into your application, as we said before, it might contain errors. So you can't perhaps process that data as you intended. And failures, we had a hard time coming up with examples for failures, but it might be because data is corrupt. It might be because there were issues with what the data looked like and so on, so you can't process it. So having an easy way to work with item failure, it's awesome. I really like these types of feature releases that makes it easier for us when building. I've always tried to focus on failures, reliability, and so on, and so I'm a big fan of all of these types of solutions.
But so Gunnar, I'm more of a fan of visualizing things, and I'm coming back to the only thing I can think of now is this app that we're going to build to get real-time feedback. So I was just thinking here that let's say that we do on this simple web page that web app that we're obviously going to be building with Amplify, because you use Amplify, right?
Yes.
Yeah. And so Amplify is, I think we say it's the fastest way to get started with a web application on AWS, because I think I like that. It's like the fastest way. It's what I've heard, and also when using it, it's really it both provides you with components for front end, and it will provision the backend for you. You actually don't need to learn how to write CloudFormation templates. I envision that our web application would then have the different emoji buttons that viewers can click to give us feedback. That would be posted to a Kinesis data stream, which will be read by a Lambda function that would aggregate the type of feedback within a certain time window for us. And then however, when it comes to visualizing this, Gunnar, I don't know if this is your area, but just kind of curious to hear. Also, I can ask you anything, right? Like how you've done that.
Well, I suppose it depends on if you want to visualize this. Is it just internal visualization? You want to have the data as to make decisions? Then an easy way is to use something like QuickSight, for instance.
No, I was thinking for just you and your I guess it could be cool to make it public, but I thought maybe first we should have us see the feedback in real time first.
No, then I think using QuickSight is an easy way to visualize data and having it as an AWS native service as well. So building dashboards using QuickSight.
Exactly, but I don't think QuickSight reads from DynamoDB, if I'm correctly, though. I don't think you can build dashboards. So I think probably need to get that into S3 somehow.
Yeah, that's right. That's right. So yeah, if you want to have the data real time, that's right. Then we perhaps shouldn't use QuickSight, as it means that we have to go through something else like S3.
Yeah. Right. Interesting. We need to. I think we need to have a follow-up session on building this app.
Perhaps. But we could. And an easy way of doing it, of course, is to make use of any type of framework like React, for instance, using Amplify. Do we call it Amplify UI these days? I think Amplify Console. Yep. And use some sort of framework like React, and then make use of the data that way. We're able to load data from DynamoDB and visualize it using Amplify UI. That's an easy way of doing it.
Yeah. Oh yeah. Right. Of course. That would our application would also. Okay. Yeah. That's good. Good point. I started. I didn't get as far as I wanted, but I started playing around with this. So I have that in another Cloud9 environment of mine. So we'll see if I can continue with that.
All right. So looking forward to seeing the rest of Sini's real-time analytics system for Twitch comments.
Mm-hmm.
Is that it? Yeah.
Yep.
Okay. So I think let's try to recap a bit about what we've talked about today. So we're talking about streaming and real-time analytics with serverless. And we started out talking a bit about the different use cases and the problem space in itself. So for people who just joined us, let's recap that a bit. What is the use case for streaming and real-time analytics?
So the use case again, it's really any type of data that either devices produce, for example, where a certain device is, like the status of it. All of this is data points that are more valuable to have in real time. It's less valuable to know the temperature of the outdoor, what it was 3 hours ago, because then it's too late to act on that. Therefore, any data that we can get as close to real time as possible brings us more value, because that allows us to act on it. And this is the real time analytics parts of it. And then the serverless part is that we like serverless because it will scale for us. It's meaning that it's easier for us to build with it. We don't have to worry about the complexity of scaling, and we also only pay for what we use. So if we don't have, if our devices aren't producing any data, then we're not paying anything. Therefore, that's why serverless is so interesting, and especially when you're just getting started, because these are managed services, meaning that it's less work for you, both in terms of learning curve and then also later on operations, because AWS takes care of more things for you at the same time as you're only paying for what you're using. So real-time analytics is essentially acting on data closer to real time. We took the example of, imagine if you could, if you have a visitor in your web store, if you could, while they're browsing, you could actually pick up on their behavior and help them find what they're looking for, rather than getting a report 24 hours later on what that user in your web store was looking at. So of course, it's more valuable to get the data while you still have that customer browsing your in your web shop, compared to the day after when they're gone.
And when we talk about this, we often talk about that it's high amounts of data, that it's a lot of data. But do you have to wait until you have a lot of data before you start building these types of solutions? Or can these solutions also help when you have lower amounts of data? Perhaps thinking about building a system that is going to grow over time.
No, absolutely. And I think, again, this is also where we see the power of serverless, because if you don't have that much data, most likely you might even fall within the free tier, meaning that you can get started and you can experiment, so no, of course, of course you don't need massive amounts of data, but then rather starting with what you have. I think another very common customer use case that I often get asked about is web apps, or just apps that we'd like to. So it's kind of like the the A/B use case. Like we deploy one version to some users, another version, a slightly different version to other users, and understanding how these different users, like how far do they get into my app? Like where do they click? Do they find these other pages? So that is like another very common use case to kind of like see how users react to that change in real time. And perhaps it wasn't good, and you don't want to have too many be affected by sort of a bad user experience. Rather, you want to like make sure to ensure that all customers get like good customer experience.
And as you said, you're able to use this as you're paying for usage, meaning that it is perhaps a bit more advanced to build these types of systems than without using streaming services like Kinesis and so on. But as you're not paying for more than your usage, you're not paying anything upfront, you're not paying for idle instances or anything like that, means that you can build these systems in a serverless fashion and then allow them to grow as your business grow or your use case grows and so on. So building it the right way from start, that's definitely always a benefit. So you don't have to change over time as your use case evolves and so on. All right. So looking at the two main features we talked about today, should we just do a quick run through of them as well? Once again, we talked about tumbling windows first. What did tumbling windows mean?
Yep. So tumbling windows allows you to define a window and sort of do analytics within that window. So for example, you may want to, so I said, like before tumbling windows, Lambda, you can of course have a Lambda function read from a Kinesis data stream, and it could do anything you wanted, any type of analytic within that batch, but you didn't know. You weren't in control of exactly the time window. And here we can set, for example, 1 minute or 30 seconds or even longer, and aggregate over that time. So we can, for example, see how many users clicked on the love emoji, or how much sales was generated for a certain product category within that minute, and then and that's even though it's quite a simple calculation to do, it can be very powerful if we can get that feedback instantly.
And the other one was I can't even remember
the
name of that one.
Here, I also had to like rehearse this. report batch item failure. It's more exciting than it sounds, but it gives us more control on how to handle messages or records that fail. So before, when a Lambda was invoked either by a batch of records, then if one message failed, then the entire batch would be retried, and possibly, depending on your workload, it might be challenging to handle duplicate records. That it's another check you have to do later on to remove any duplicates. So therefore, with a new function response type is this report batch item failures, means that processing when in the batch, when a message fails process, perhaps maybe it's corrupt, maybe it's missing data, then that batch will no longer be processed, but rather it will be reported back. And on the retry, none of the successful records will be processed. So it will just be the unsuccessful and the remaining ones, so to say. So fewer duplicates records to have to handle, and greater control for us who own the Lambda function to decide what we want to do with failed records that failed to process.
And these batches, they can be from either DynamoDB streams or from Kinesis Kinesis data streams. Yeah. Sorry.
Exactly.
Right. Okay. So that's what we've covered today, talking about streaming and real-time analytics with serverless. Really interesting topic, and one that gets more and more, I think it gets more and more attention because, as we said, we're generating more and more data all the time, and we want to make quicker decisions based on that data all the time as well. So this is really interesting. I think this is something that we could dive even deeper on a future episode. When you've finished your application for real-time Twitch comment analytics, then we'll have you back on, Sini, to talk about that. I want to thank you for joining us today, because, as I said, this is a really interesting topic and one that deserves attention, definitely. Before we leave, let me just get back to this. If you find this very interesting, if you have any other technical areas you want to talk to AWS experts on, well, make sure to go to the webpage for this office hours and click on the orange button and schedule a meeting with AWS experts, a one-on-one meeting to discuss your use case with solution architects and others from AWS. And of course, also do join us. That's black. That's the right one. Do join us next week and the upcoming weeks for other exciting topics. We're going to talk about serverless ops with Nicholas next week. Then we have containers with Andreas. We have AI/ML with Kesh. More machine learning with Anna-Maria and Yasir. A secret episode and a database episode with Tim, and much, much more coming up as well. So join us every week, 1 p.m. CET. All right, with that, Sini, once again, thank you very much. Thanks everyone for watching, and thanks for the questions we got. And thanks to everyone who joined us today. All right.
Thank you so much. Bye.